Hello and welcome to another free code session. My name is Jason Bach, and I want to try to finish up this constraint stuff, or generic stuff I should really say. So for me, last night I had got the constraint stuff generated. Now I actually have to add it to the right spots, which is with all of the with the type generation, the method generation, property generation, indexer generation events. Can you have, I guess it's possible, and it wouldn't hurt to call it. So, yay. All right, so let's get to it. So we would be calling get constraints. Okay. Excuse me. So let's go back up here and let's go to the builders and let's go to where we actually create the builder. So we do using, and then we have to go to mock extensions builder and ignore the to display string, Jason. Stay on target. Stay on target. Okay, that's right. Because as I learned a while ago that you have to actually build this within the expectations. Yes. Okay. So we come here, we build that, or we say we inherit from one of those. Then we would have in here, we'd say something like var constraints is equal to information type to mock. Well, wait a minute. Okay, so this, the thing that went through my head right now is, okay. Because remember when I talked back here about should I actually let the given type be an open generic? And I thought last night, could I actually allow this? In that I thought there was going to be some case that I ran into where it was going to fail. But then I thought this morning, I can't think of it again. And I don't know why that wouldn't work. So the reason why I just hesitated right now is because if I come back here, if I decide to support generics, then yes, I would need this. If I didn't, I wouldn't have to do this because there would be no generics anymore. The type would be closed and the constraints would have been satisfied, blah, blah, blah. So we're going to do, now do I do it on the type parameters or do I do it on the type arguments? I believe I would do it on the type arguments. So here's the other rub, which if I say if, okay, how many times, what's introduce local for? Yeah. If type to mock type arg, oh crap, type arg, yeah, is I named type symbol, named type, and named type dot type arguments length is greater than 0. Then we need to get var constraints is equal to named type arguments select get constraints. Come on. No, come on. Oh, please don't tell me that they're type symbols. Ah, crap. Well, we would only want these if they weren't satisfied. Right. So we're going to have to say, I believe, for var 0 I less than named type arguments length I plus plus. No. No. Stop trying to type so fast, Jason. Knock it off. This isn't a speed contest. Okay. If var type argument is equal to... yeah. Just keep going. Okay, so var type argument is equal to named type arguments of I if type argument equals named type parameters of I. They don't. Okay. No. And the reason why I'm doing this is because I believe you only would omit the constraint if you actually, because if you go here, type arguments, it says returns type arguments submitted by type parameters. Nothing has been submitted, then the type parameter itself is considered the type parameter. Okay, and if you look at type parameters here, the type parameters, this is name type symbol, type parameter symbol, they're still symbols. I would assume then that if you haven't, they would be equal. Actually, no, I want to say if they're equal. Because if they're equal, that means it's still open. Okay, so actually what I want to do is let's pull this all into get type constraints. And, it's never easy, is it? Var constraints is equal to mock create build, I get type constraints. And I want to return this as an array of them. Okay. So we're going to say var constraints is equal to a list. No. And then we're going to return constraints. List of string. There we go. Okay. Constraints. Add the type argument get constraint, except you can't do that. I think I'm going to have to reverse all this. Yeah. So we're going to want to say, because type parameters, like reverse all of it. Type parameter. The type parameter equals type arguments, then we just do this. No. TP. God, you really can't do that? Okay, so you should see the where there, the where there. And the whole point of this is that I can then omit this back. Okay, so then I say up here, if constraints that count is greater than 0, then for each var constraint and constraints. So I've already indented that because I want to put, yeah, so we'll put the outdent after. Okay. So then we'd say here, writer.write line, and we would put in the constraint. And it's just that simple, right? Yeah. I think that's pretty much it for that one. Okay, so now what? So we did this for the type. So this should all have the stuff there, the constraints there. Now we need to do it for each method and each indexer and each property and each event. Okay, wonderful. I kind of want this get type constraints thing to be a somewhat generic. See, this is, yeah, because if you look at type parameters here, type parameters is defined on the named type symbol, right? But if I am almost positive, if I go over to a method here, a mock method, we'll just say value builder, okay? And I say method.type arguments. What do you think this is defined on? An I method symbol. Okay. And I bet in here there's type parameters, yeah. So this is where I would like structural typing in C#, because I would love to be able to say, as long as I get something that has these two properties on it, then take it, even though they don't share a type. But I can't do that. So this is unfortunately where it becomes helper method time. You know, there's no other way to do this other than kind of sort of, we're going to say constraint builder, okay? And what this does is it's an internal static class of constraint builder. And what this does is it's going to return internal static. We're going to be right. We're going to have mutable array of string. Okay? And we're going to say get constraints. But we're going to get constraints. God, you suck. Type parameters. Type parameters. We're going to put this on the next line. And then we want type arguments. Type arguments. Do those just come from, where do those come from? Okay, so those are on the named, how did I, oh, type, whatever. It's morning on a Sunday. So we will put in here type arguments. Okay, great, great. Yes, so now we're going to pull all this there. We're going to do this. We don't need to do this check anymore. What we could do is just say if, and, well, I'm trusting that I am not a stupid developer, and that's a bad, that's a bad thing to do. But to immutable array. The thing that what I was going through my head there in a moment was just, why would I give two immutable arrays? These would be coming from Roslyn, and they should always have the same, number. So we don't do this here anymore. That should cause an error up here. And what we say is constraint builder get constraints based on what do we pass in here? An immutable array of type parameters, type, oh, yeah, if type 2 mock is I named type symbol named type because reasons. We go down like this, pull that in there, and now we say that, and now we say named type parameters, and this is the type arguments, named type arguments. And now it's the length. There. So same thing, except now I can use this in other spots. So that's a little bit, I think, nicer. Okay. So this will do that for that. Okay, so then let's go to method value builder. And we want to, member identifier is public. Now here is where we would want to indent if there's constraints and then outdent for the opening thing. Okay, so var constraints is equal to, constraint builder dot get constraints for method dot type parameters, method dot type arguments. If constraints dot length is greater than 0, writer dot indent plus plus, and we will eventually come back out. And we should say for each var constraint constraints writer dot write line constraint. Okay, and then indent minus minus. Okay, so that's the value builder. The void builder should be almost exactly the same thing. We don't need that. Put that in there. And that's that. So the methods are done. What about the properties? Property builder, build getter, build setter. This is, I believe, where you'd say the same thing, except this time, where are we getting the, how many times do we do resolve value? Not a lot. Well, property. There we go. Property type parameter. Oh, give me a break. Why wouldn't it? Is it just not Rx is equal to thy named property? No. Am I rethinking my things? So if I have here like a public class T, and I say here public, X of, data X of X, get set. You can't do this. You could use T, but then the wheres would be up there. So I don't think, I guess with properties, and indexers would also be the same thing because indexers are properties. So you wouldn't have any constraints on properties or indexers, which makes things a lot simpler. Which in other words, this all goes. Which is fine because we made a nice little edit into our property that we captured this, and now we need to do events builder. I don't think here, I think it's the same thing. There's no way for you to define generic events. So like if I said here event.type, there's nothing like that. So we're good. In other words, I think this is done, except how do I know that I'm actually omitting the constraints, right? So let's go over to here to write a test real quick and see if we're doing the thing that we're supposed to be doing. Okay, so I have something already set up here, except I want to say IMOC of u, where u has to be a struct. Okay, and then I want to have here u struct value, where that has to be a class. So what I would expect is that the resultant mock type, so let's now run this. First of all, let's make sure that we've got all breakpoints gone. And then let's come here and do that. What am I doing? You moron. It's like, I know. I don't care. That's what I wanted to do. Okay. So Once this gets up and running, what will it look like? Bad stuff. Why? Namespaces. Okay. Names count as 5. Null. How did I get a null in there? That is bizarre. Well, a little surprising. I guess maybe, yeah, I wonder if you can do something like a, wait, where do the usings come into play? Those are at the top. For each namespace where, okay, this came into there. That's the only spots that actually comes into here. So we can say where this, no, is not null, and that's that. Okay. I think what happened is because there's a generic in there, I think it, oh, wait, whoa, that's also wrong. Hold on, stop. None of this should work. Note to self, hold on. If I define the type to mock as something like I mock T, and then I do rock create I mock, that's just wrong code. Need to make sure we don't generate anything if there are issues with the code. Check diagnostics. Okay, this is something I've done before, I think, on other analyzers and stuff that I did, which is you don't actually try to do something if the code is in an invalid state. Only when the compiler itself thinks it's correct. So in here, I'd have to say something like int. Now that's correct because int is a struct and everything should follow through. Okay, let's do this. So, yeah, I know. That's okay. I should have put a breakpoint there, copy value. So let's do all the magic with the delete home, because you won't do that. That, H, RN, normal. Okay. So what do we got here? Nothing. Well, this is right. Okay, so it did the right thing here. Oh, because, yes, that's correct. Okay, so that's right, because there's no need to define it here, but I do need to put it here. So this actually did the right thing. Okay, that's fine. And you'll notice here now it's doing that all correctly, and that's fine. So cool. Now let's actually do it. So we will do test of Q, where Q is a struct, and I do I mock a Q. Now what's going to happen? And this is kind of, in a funny way, this is going to just prove out how far along I would need to do something like this, you know? So let's see what we will see. So what I will see though is that copy value. Okay, come back over here, do that, put that down there. And I'm sure if I just like squinted hard, I would be able to see if, nope, it didn't do it. Rock IMOC of Q, it doesn't put, it does all this right, which is kind of nice. And it casts that correctly. Yeah. So that's actually kind of really close. The problem is that it doesn't make this generic, which is fine. I would need to change that. I would actually need to pass in the Q here as a parameter to that, which is expected. And then these are all Q extensions. So I'm really close. I'm just curious, before we close this out, why did it not on the mock create builder here? Because it should have been telling, I mean, it does for the method. So why would it not here? Let us see what we can see. And then I'm going to stop this recording. So it isn't named, well, we don't know yet. Okay, so we have one type parameter and one type argument. Let's actually dive in and see what we get. So we should have that, get type parameters, we get a type parameter. Type parameter is a U. Yes, because it's a struct. Okay, I was being an idiot. Okay, so yes, it's a U, and it thinks it's a Q. Okay, so I kind of, well, ain't that cute, because it passed it in as a Q, but it's still open. Well, that's funny. That's really freaking funny. Okay. Type parameter. It is a U. Type arguments of I. It's a Q. Is generic. Is abstract. Is anonymous. Is definition. Nope. Is implicitly declared. Is override. Is reference. Sealed static. Is tuple. Is type. Is virtual. Generic. Nope. Well, this is, it's a type. Type. It's a type parameter. Okay, so I think if the type argument is Q and it's saying it's a type parameter, okay, what would happen though if you actually passed in an int? Okay, let's come back here. Get to this. Because I'm wondering if I'm going to have to use that in some way, shape, or form. So we say that. We step in. It's a struct. It's not a type parameter. Okay. Now they're not going to equal, and that's okay because that's going to be funnish. Yeah, I'm going to have to do this in the next episode. The thing that's going through my head is, okay, if the type argument, the thing that's given to you, is a type parameter, that's fine because I pass in a Q to the type parameter. But what I still need to put in is, and this, yeah, I'm going to have to take a break again because this is now swinging the balance of, do I support open generic mock types? Do I really want to go down that road? Because what I would be generating is something like a type for any arbitrary, like mock of, well, what I'd really want it to be is the type parameter name, not the type argument type that I've been giving it. So yeah, I got to take a break. I will come back to this later and determine, do I really want to go down this road of supporting generic mock types? And it's not even a question of can I do it in the sense, sense of can I physically do it or not. It's, is it really that necessary? Like the use case again is I'm mocking a type for a test. where would I ever come up with the need for somebody to write a test so complicated that it would actually need to say I service of T, where the T is going to be passed in later. Just let's just not even do that. So, but I will determine that later. So thank you all for watching. Leave comments and questions below. See you in the next episode.